to start our day. It is the 17th all day long. I don't know exactly how far we're going to get. We will, your practice assignments will just be whatever to match however far we get. So this got it is where we ended yesterday. So Monica, is this the one that you were talking about?
Yes.
What was your question?
What would be the constant? Would the constant here? Because somehow I only got down 3 things and I'm not sure what.
So we had here 4 terms.
Yeah.
I had 6p as a variable term, negative 7pc as a variable term, and 9c as a variable term. My constant, we always assume that we're adding between values. So there is actually an addition in here that is not notated. So we're adding the value of negative 4. So our constant is actually the negative 4.
I was asking about how does that negative, where is that
Coefficient
negative go? Like, does it automatically go to the constant? Or can it still go to the coefficient?
So it's whatever sign is in front of the term. So here, the coefficient is negative 7.
Mm-hmm.
Trying to figure out why I have 2 smart inks open.
Wait, Mr. Husband, did you put back up 7-1?
No, so about 7-1. 7-1 is gone and dead forever.
Yeah.
So the assignment, something glitched out. Whoa. Something glitched out, and it is no longer part of your homework. So do not worry about it at all.
I didn't do it.
Apparently technology is not functioning with me today.
Yeah, the smartboard didn't.
Yeah. So go ahead and move on to the back and check out that first part there. Let's see if I move on. What is wrong? There we go. Bring Smart back. So now we get into like multiple expressions written together that really are still one expression. But here I have like this binomial, negative 5x plus 4, and this binomial, 11x minus 9. I believe I've gotten everything smart fixed again. What really caused that issue is I had to take my cable from the smartboard into the family room this morning to do that presentation. Then I had to hook everything back up. So we have 2 different variable terms here, 2 different constant terms. But when we look at our variable terms, we see that they both have the same variable, and that variable has the same power. You're not going to see variables with powers for a little while, but once we have exponents or powers on those variables, those matter also for determining like terms. So the negative 5x and the 11x can be combined together, so we apply whatever we need to combine these terms. So the first thing we look at is what operation is in between them, and that has to distribute into here. So we're going to add 11x with whatever other term we can. We're going to add a negative 9 with whatever other term that we can. So then I can rearrange these, and they actually rearrange and then factor. So just give me your eyes for a second so that you understand what happens here. We start with our 2 variable terms separated. They apply the commutative property and the associative property at the same time. They change where things are, they move or commute, and then they reassociate, or what's grouped together. Now my variable terms are together in that parentheses. So both the commutative and associative properties have been applied at the same time. Yeah?
Never mind.
Okay. So they do the same thing with your constant values, but my constants are 4 and a negative 9. So then those come out here, 4 plus a negative 9. Then we can easily combine the like terms. They actually apply a step right here that I don't think is totally necessary unless you want to really think it through. They pull out the x, so they factor, and then they look at just the coefficient values. They combine those and then apply it as your 1 coefficient. You don't have to do this middle step. You could just say negative 5x plus 11x will give me 6x, and a 4 plus a negative 9 will give me negative 5. And then I clean it up because I don't need to say plus a negative, I just say minus. Any questions on how they did that? Or how this is done? I used to say they as in Pearson, but we don't use Pearson anymore, so it's just like, yeah. All right, so moving on, I want you guys to go ahead and try that with at least the first two here in the example. You may chat with your partners close by. You may stick up a hand if you have a question. I will come around and help. I would advise color coding. I'm actually going to run and grab the water really quick.
I think this is it. Wait, this together. I'm thinking about the first
I'm going to give you about another minute, then I'm going to use cards.
Just put vitamin water in your coffee.
That's not coffee. It was juice this morning. My stomach's still too iffy to drink coffee.
You've been drinking
Maybe by next week. Yeah, I just needed something to
What
put juice in.
happened?
I got food poisoning. And like my stomach reset. It's like literally everything was out of it.
from top.
So then your stomach has to like reset. Because your stomach is a really fancy scientific experiment kind of going on at all times. The acids and everything that have to mix and process your food. So when you throw up a lot, you mess up that balance. So that's why like yogurt, like Activia, certain juices and things with electrolytes and stuff like that, it helps your body kind of get reset. So, Whitney.
I just wanted to tell you like something about have you had to get your appendix out? Well, my sister had to do that.
I have not, luckily.
Yeah, but like she had to do that and like she like threw up everything. It's kind of like food poisoning.
Yeah.
It's like worse and then you have to go get surgery. to get it out.
I can imagine. So Jaslyn, here in this first expression, what like terms are able to be combined?
2r and negative 5r.
Yeah, so if I want to first apply the commutative property, I could rewrite this with those values beside each other. 2r, negative 5r, plus then 7. All I've done is the commutative property, unless I put parentheses right here,
That's what I did.
and then I've applied the commutative property and the associative property,
That's
because then I reassociate. So either way is totally fine. This just cleans it up a little bit with my green parentheses added there. So then what do you get for your R value, Jaslyn?
For my r value, I got 3r.
Ooh, close. Careful, which one's stronger, the positive or the negative?
Oh, negative 3r.
Yeah, so we get negative 3R plus,
7.
because nothing happens to the constant, it just stays 7, and that is my final answer.
Oh.
For the second one here, Jeremiah, we'll go ahead and take a hand on this one.
I got negative 2r plus 15.
Negative 2r plus 15. Let's check that. So you kind of jumped right through your process, but you took your r value and your r value. There's really a coefficient out here of 1 that we don't need to write. So we have 1 minus 3, Jeremiah says gave him negative 2r. And then you combine your constant values 4 and a negative 11.
Oh,
And
that's
maybe you should have written out your work instead of jumping right to it.
Then it's
Oh, I
negative
thought we were supposed to simplify and make it into another equation,
negative
not
7.
solve it.
This is not an equation. Let's get that very clear right now. You are simplifying the expression by combining the like terms. That's all we're doing.
Well, then it's
I didn't know we were supposed to give an answer though.
it's
so I
negative
didn't.
7.
But when you simplify, that is your answer. Like, we're not solving anything. We're just simplifying.
Yeah.
Here's the issue, though. He, when he went to combine his 4, forgot that the 11 was negative. So we get negative 2r, but then my constant value
Plus negative 7.
plus a negative 7. Or instead of saying plus a negative, I can just say minus 7. So negative 2r minus 7. Any questions how we got there?
Wait, 4 plus. Oh, wait, wasn't the 11
The 11 was negative. So when we combined 4 and negative 11, think of it as either 4 minus 11 or 11 minus 4, but then your answer has to be negative because the negative was stronger. Remember, when we're adding with different terms or different signs, we say which sign is more powerful, that sign will stay on the value. Then we find the difference between them because they're different signs. So think about being at 4 and going down 11, it takes you to negative 7. Make sense?
Can I do the next one?
Sure. Ozzy, go ahead.
All right. The first thing I did, I looked at that number, and then what's it called? Not to simplify, but like, is it to oversimplify or?
You talking about where you do the arrows?
No, like you make it bigger again.
Expand it?
Kind of, yeah.
Yeah, so the first thing we really need to do here
is change it back to how it was before. So you put 5R and 5 inside the.
So what's that called? It starts with a D.
I'll distribute.
We are going to distribute.
5.
So when we distribute, and I'm going to use all my space here because, guys, I'm going to run out of space. So I'm going to come up here for my first step. Ozzy's saying we get 5R plus 5 from that distribution. Then I'm going to change colors just to keep this straight. My plus, negative 8R plus 2. Nothing needs to happen with that. But if there was a number out here, we would also distribute that, which you're going to see that on your homework, where both of those have a coefficient that needs to be distributed. So now these parentheses aren't really necessary. So I can like kind of in my head get rid of them, and then I could rearrange. So if I rearrange, what like terms can be combined, Ozzy?
5R, 8R.
5R and what R?
8R.
What?
Negative
-8. That's where the biggest issues come in, is people forget their negatives.
And then 5, and then 5, 2.
5 and 2. And if we want, we can say my variables are together and my constants are together. 5R plus a negative 8R gives me?
R times 5 plus negative 8.
Oh, so you factored it out. I love it. R times 5 plus a negative 8. Plus, I can go ahead and
7.
simplify this into 7.
And then do the math there. So it would be negative 3R
Yep.
plus 7.
Annie,
Get that.
which part? Where did it fall apart for you?
R times 5 plus negative.
Oh, because
So he factored the fact that we have a common factor of R in both of them. So he divided by R, which brought it out front.
Oh.
This is like what I was helping you with on your homework. Then your coefficient values are what's left. Then they will get combined, and that's how you get your negative 3. Now you don't have to do the factor step.
Wait.
You could just add these together and get your negative 3R. You don't have to do the factor step.
Oh.
It can help you though, especially if you have multiple variables.
Okay.
Yeah, Julie?
Are you going to reassign 7-1?
No. So you weren't in here when we were talking about this. 7-1 is gone and dead forever. The future 7 homeworks, like the combined, I forget if it's 7-3, 7-4, or 7-4, 7-5, whichever one it is, you will see that is going to practice your distributive property. 7-1 was mainly about expanding, using the distributive property. The homework got goofed up. The answers changed what was right and wrong, and the zoom. I don't know what happened, but I was too frustrated, deleted it. I'm not going to waste your guys' time. The future homeworks will check that you understand that stuff.
7, 3, 7, 4 is not.
Yeah, 7, 3, and 4. That's where you have to simplify and combine the algebraic expressions. Guys, I am telling you, I am begging you, write down work while you do this. Otherwise, you're going to get them wrong. You're going to waste your time. Trust me. I've been there. This is my 5th year. I know what mistakes people make. Write down the work. It will save you from those mistakes. So which expressions are equivalent to our negative 6 plus 5t? So I want you to go through and check each one, how the variables would combine, how the constants would combine. I'm going to give you a minute to do this. I'm going to color code up here because that's how I think. My brain works in colors. Whitney, what issues do you see with a couple of these?
In number 1, that's not equivalent because we start off with like 8t plus negative 3t.
So what would 8t plus negative 3t be? Like if we just look at these
5t.
5t. So wait, that works with our 5t.
But it doesn't. The other one, 13 plus 7 equals 20. It doesn't equal 9.
Ah, so the constant makes it fall apart. Number 1 does not work.
That's annoying that they use T as a variable.
Yeah, that's when I make assignments, I try to avoid it at all costs. But on the computer, it doesn't look as bad as like when you write it. So a way that you can avoid that, use capital T's.
Or just like add a T like.
Or add the
Yeah, do cursive T. Noah, what about number 2? Do your T's first. T and 4t, what'd you get?
Would that be 5t?
Yeah, because this is really 1t plus 4t gives me 5t. Then I have 9 and negative 15.
Oh, that works.
What do you get from that?
Negative 6.
Yeah, negative 6. We get a negative 6, a positive 5t. That's what we wanted. Number 2 works. Now number 3, Elena. What about number 3?
I didn't really get this one.
Okay. So when you look at number 3, what would be the first thing that you think we should do?
Put the negative 2 in the 4.
Ooh, you're falling in the trap. Always think about order of operations. We can't do my parentheses. There are no exponents. Is there any multiplication or division?
5 times negative 2 and 5 times t.
There. I was going to say that's what it is, and there it is at the same time, apparently. That's what we need to do. So my 5 times negative 2, that's going to give me a value of... So what would 5 times 2 be?
10.
10, so it just becomes a negative 10. 5 times t becomes 5t. And then I still have my plus 4. So when I go to combine those constant values of 4 and negative 10, would I get negative 6?
No.
Yeah. This is one of the trickiest things with 7th grade math, is adding and subtracting positive, negative numbers. So I have my 5t, I have my negative 6. Number 3 also works. Let's see if number 4 works. Ashley, can you walk me through number 4?
So what you would do first is you would do 2 times t,
And that would give you
2t,
2t.
and then 2 times negative 3,
Yeah, and that gives you
negative 6.
boom. So I can copy down everything else. These parentheses right here aren't really doing anything. They're just grouping a binomial. So when I rewrite all this, I have a negative 1 plus a 2t plus a 3. Yeah, and this is where the t's really get annoying. So I'm going to color code constant, constant. I missed a plus sign. Constant. So let's combine all these. I already start with a negative 6. Then I have a 3 and a 1. So negative 1 takes me to negative 7. Then I go up 3. Where do I land for my constants?
Negative 4.
Negative 4. When I combine my variable terms, 2t, 2t, 4t. Does this one work? No, we get a different result. So 2 and 3 work there. So it would make your life easier if we apply the commutative property to rearrange and put my like terms together. If you don't have highlighters to help you color code, I would always rearrange.
I'm confused with the negative 4. Think about that.
So we took negative 1 plus 3 would take you to a positive 2. Then from positive 2 minus 6 takes you down to a negative 4.
Okay. Then what happens? That's a 4t.
Yeah,
Oh, I
so
thought that was a plus
the
sign.
yellows go to here, the greens go to here. Yeah, and that's why T's are annoying. Try to avoid those. Julian?
For the third one, why wouldn't you multiply the 5 by the 4?
Because it's not in the parentheses. This is 5 times
Oh, yeah.
anything in here. Great question, though. I appreciate that. Andrew?
And the T's, see how they do it? They kind of do it kind of like a J-ish. That's how
Yeah, that's the print T.
Was that a Snapchat?
No, it was my sister from South Carolina.
Oh no. Why was she texting when something happened?
No, she's asking me about pictures from the trip. Sorry that my phone was not on silent. My sister's an artist, so she has a different kind of schedule. So now we really use expressions and equations to make sense of problems. So here's our problem. We have a rectangular flower frame, or a rectangular frame for a flower bed is 9 feet longer than it is wide. So if we draw a picture for this, because drawing a picture is always a good way to start. How could I label this? And this is not drawn to scale. I would probably need to have it be a little bit longer rectangularly. How could I label this to represent what that told me? Ozzy, what do you think? How could I label this picture to represent this?
I'd put I make a 9-foot mark along the length side, so you know that's at least 9 feet long.
Okay, but we can't like measure, because my paper's not 9 feet, right? So I can't actually measure.
I know, but you can like make like not a to scale.
Yeah, but that 9 is not really referencing a solid length. It's like 9 longer. Like how would you represent the width in this situation?
W.
Sure, let's say it's W.
W.
So then, how could we represent the length?
L.
It's, if we can avoid introducing another variable, we would like to avoid that. Noah?
W plus 9.
If it's 9 more than, we could just say W plus 9. And then down here will be W plus 9. So then we want to write an algebraic expression for the perimeter. Well, we know that we find a perimeter by 2 times the width and 2 times the length. But instead of using 2 different variables, we can substitute our length with the length that we wrote. So now our perimeter can become our 2W, because we just said our width will be W. But the 2 times the length can now, the L can be substituted by
9 plus W.
yeah, the 9 plus W or the W plus 9. We kind of like our variables to come first, so I'm going to write it that way. Sean, what would I need to do now?
Use the distributive for it.
Use the distributive property. Which, guys, sometimes, especially if you work in colors, I will often write off to the side, like, okay, this distribution gives me 2W plus 18. And I know that because I drew my arrows in red and I wrote that in red. So if you have colors, this can really help you. Now when I go to put the entire perimeter together, I have 2W plus 2W plus 18. And in the end, once I simplify that, it's going to become,
4W plus
you caught yourself, but yeah, 4W, go ahead, class,
4W.
plus 18. So as soon as you know what the width is, then you can figure everything out. But until we know what the width is, we don't know the perimeter. Try the got it. I need to see like where you started before that to see if that substitution's accurate. So again, we're looking for perimeter. And again, I'm going to use space that is not this problem. So ignore that I'm writing up in the example space. We know that perimeter, and I would advise you to start with a general formula that you know. We know perimeters 2 times the width, 2 times the length, any quadrilateral. So Ellie, what you do here based off it telling you the width of the rectangle is 1/2 the length.
Well, what I did was I drew a rectangle, and for the length I put L,
Sweet.
and for the width, and for the width I put 1/2 L.
Perfect.
Yeah.
Or we could also write it as L over 2, just like L divided by 2. Either way is the same thing. Some people just like this better. So continue.
And I'm trying to write the expression, which is kind of harder for me because I'm not 100% sure what I'm doing.
Yeah, so this is why we always start with a nice, easy, like this is kind of an equation because we have perimeter equal, but we don't know what the perimeter is. So still, we're really just writing an expression for the perimeter. We know it's 2 widths plus 2 lengths. But now I can replace the width with the width that we know. L divided by 2. Andrew, I think you had a W out of place
I
somewhere.
put the L on top and the 2 on the bottom. Oh, wait.
So our width is just L over 2. You had written like W plus L over 2 or something. Just check
I
that.
did that, yeah.
Okay. So now, so if I have 2 times half L, 2 times a half, Colin?
It'd be a whole.
It's a whole. So this will become a whole L plus the 2L, and my perimeter ends up being
3L.
3L.
Wait, I'm
Because the L counts as 1.
2 times L divided
2
by
times a half. So this right here represents half of the length. And whenever you double a half, you just get a whole or a 1.
Oh. So, yeah, that makes sense.
Any questions, comments, or concerns? Flip to the 7-4. So we will be speeding up as we go through this because it all kind of becomes repetitive. You're going to get better and better as we go. So subtracting algebraic expressions. Give me your eyes for a minute. The biggest mistake people make is right here. Come on. Because this is saying the opposite of everything in the parentheses. So that, when applied, goes here and here. The opposite of the 2 and the opposite of the -7. So the opposite of the -7 becomes a +7. This is where people screw it up. My best advice,
I didn't have
again, apply arrows. If I know that this is going to subtract or apply the negative to both of these, that first arrow is right here. That second arrow is right here.
I don't get what the 2 is.
Because it is subtracting everything in this parenthesis. It's saying this value minus that value. So if I were to write it out without the parentheses, we're subtracting the 2 and we're subtracting the -7. But that's weird to think about because you can't subtract a negative. It really adds then.
Wait, isn't. Oh, minus negative.
Doesn't it start as a positive?
No, this starts as like, well, so it either starts as a -7 in the parentheses or a -7 if you think of that as 2 plus -7, x. So either way you think about it doesn't matter, but if it's the opposite of a minus, it's addition. If it's the opposite of a negative, it's addition. So either way, we end up with positive. That's where people make their mistakes. So please be aware that minus or that negative has to be distributed to each term in that expression. And you have another example right here showing you if I think about it, instead of as being a minus, Now they've made this a -1 that they then physically distribute the -1 to both values. So for some people, it might be beneficial to turn this minus into plus a -1, and that -1 actually multiplies. What don't you get? You got to be
Why you turn it into a -1?
because does multiplying by 1 change anything? No. Subtracting is essentially applying the negative or the opposite, right? Compared to addition. So instead of just saying subtract, we want to assume addition, right? We could say this is really plus a negative. But instead of saying plus a negative, well, negative what? We give it a -1 to say 1 doesn't change the value, like the numerical, but the negative changes the sign. So both of these are the same process, just done differently.
I only understood the first.
That's fine. Then do the first way. That's why we're giving you options. So let's try it. Down here, we'll walk through a couple together. First thing I want you to do, draw arrows from your minus into the 3 and into the 8m. This then becomes 16m. Always assume addition. So plus, well, what was the minus / the negative times 3? -3. So this becomes -3 plus, always assume addition and then fix it when we when we pretty it up or clean it up, sorry. Negative or the opposite times the positive 8m is again -8m. So now, yes, you could just write them as minuses.
Wait, I have a
Why
question.
couldn't you just keep it that way and just use the commutative property?
Wait. I still
You
don't-
can't use commutative property here because you have to apply the minus to both of them. You can't just move things around. So you could, hang on for a second, you could just skip right to this step if you understand what you're doing. We're subtracting the 3 and we're subtracting the 8m. But if we distribute the subtraction as a negative, this step is nice so that we can actually think through what are the values and then make it subtraction. Ozzy.
Why would you change the 8 to a negative? Because that's still adding.
This is applying subtraction to everything in the parentheses.
Okay.
We are distributing the subtraction. Any other questions? This is weird to understand. I get that. This is hard to get over. So then, rearrange with your commutative property. So now I'll have 16m. Guys, we should all be writing. I see a lot of people not actively writing. Now we can move it around. Make sure that you keep the sign in front of the term with that term. And that would become
8m minus
8m minus 3. Questions? Do you already have this all written down? Yeah.
Why would
go
we
on.
need to know this in real world?
There's a million applications. You got to learn how to do it before you can learn how to apply it. So I love the question, but you have students who barely are getting through the problem right now. Hang on to it. We'll apply it. Like, part of your mathematics education is just learning how to problem solve. It's not that you're going to take that expression and it relates to something real world. But depending on what career field you go into, you're going to use your problem solving skills. You're going to use your attention to detail. You're going to use your arithmetic knowledge. You're going to use your multiplicative knowledge. You're going to use the fact that you practiced all of this till you were blue in the face and you understand it so well that you can put a man on Mars. That's the goal. Like, guys, every advance that we've had in society is because people sat in classrooms and they learned things that they thought they were never going to use. I don't want to go there, but I'm just saying, you need to understand, it's not that this is going to be applied to the real world. It's the skills that you're building that are going to be applied to the real world. So here, let's do it the other method. That's going to make Monica angry. But let's do it the method where we switch this to addition. So I'm going to run out of space. I already know that, so I'm going to have to use a bunch of my board. But rewrite this as a 1/3 p minus 9 plus a negative, but you can't just have like a negative sign floating there, so it has to be a negative something. So we say -1, then applied to the 4th p minus 1. Telling something to subtract is the same as a multiplication by -1.
So the subtraction there, you're turning it into addition, but because you're switching it, you also need to make you need a subtraction. But
Well, now we don't look at it as subtraction.
But doesn't
We've
the
made it
negative one-
addition of a negative.
But doesn't adding a -1 still change it?
No, we're not adding a -1. We're adding the negative of these values. We're adding the opposite of
either
this.
way you'd have to do that.
Either way, you get to the same place. You don't have to do this. You could just apply the negative to both of them. This is just another method that I want us to practice and be
I
familiar
think
with.
why I'm not getting it is because the -1 is like a separate thing. I'd get it easy if there was like a parentheses bit over the addition thingy stuff. Like the -1 and the 1/4 p minus 1.
Like this?
Yeah, that like puts it in
Yeah,
like
that's
one
what I
big
was
blob.
Sure. Yeah, do that then. You can add as many parentheses as you want to group things together. Because then I could add another set of parentheses that groups this problem together. They're unnecessary, but I can. So, now we distribute. We apply that negative. So, the -1 comes to the 4th p. This is where people make their mistakes. The -1 comes to the already -1, which is going to turn into addition. So, again, none of this has changed. So, we have 1/3 p minus 9. Now, we have that addition. What's my first term from my distribution? What's the opposite of 1/4 p?
-1/4 p.
So it's a -1/4 p. Assume addition. We have the opposite of a -1 or a -1.
1.
Positive 1. Yep. Now get rid of your parentheses to clean this thing up and rearrange to put your variable terms together, your constant terms together. So we have a 3rd p minus a 4th p minus 9 plus 1. Here's, if you're confused how I took those steps, the 1/3 p came to here. The -4th p came to here
Wait,
with
so
its
people-
negative as subtraction. Then minus 9 came out here. The sign in front of it has to go with it. And the +1 came right here.
So wait, even if it's addition and subtraction in the expression, you can like still like use the commutative?
You can always make addition, subtraction, or subtraction, addition. They're the same thing. You just have to play with it a little bit. I can make subtraction into addition, but it's got to be addition of the opposite or the negative. Ozzy?
Can't you just use the methods we were using in 7.3 to solve that to get the final expression?
As long as you pay attention to what sign, like, you'll get the wrong answer if you just immediately try to combine these, because you'll put -9 with -1 and you'll think your answer is -10. It's not. Because when I come out here, -9 now has +1.
No, like for transition word now.
I believe the short answer is yes, you just have to be careful. Hold up, we got to get our answer to this. How do I combine a 3rd and a 4th? Common denominator. So this I could really think of as 4/12 minus 9/12, or sorry, 3/12. So we get 1/12 p minus 8.
Where did you get that? Pretty cool.
So these, we can review this tomorrow, but this really becomes 4/12 p minus 3 plus p. Because when I make these common denominators, I multiply here by 4, I multiply here by 3 on top of that.
Okay, minus.
So 4 minus
When
3,
you give me 8.
negative 9 plus 1 if I'm at negative 9 and I go up 1.
Got it. So you're not actually adding the 1, it's to negative 9, not the positive.
Yeah, we did that first thing this year, adding and subtracting the positive and the negative.
Yep, I got
Yeah,
it.
so you just gotta remember those rules.
Okay.
I mean, I am.